Hello students, we will be discussing about the summary of the chapter hydrocarbon and basically the second half of the chapter. So we are going to start with Markovnikov's rule. We have already studied this rule before in some basic concepts of organic chemistry, but we are going to just have a quick revision of what we have done in the previous chapters. So here we have got Markovnikov's rule. And what you have to remember is the Markovnikov rule is basically applied on the unsymmetrical alkenes. And we have discussed it before that what are basically unsymmetrical alkenes. That means if you pass the plane of symmetry through the double bond, they will not be able to divide it into two equal halves. That means they won't be symmetrical at any point of time. So that is what is called as unsymmetrical alkenes, and Markovnikov's rule is basically applied on unsymmetrical alkenes. So here we have got the statement of the Markovnikov's rule. The addition of HX means halogen acid. Okay, so it can be hydrobromic acid, it can be hydrochloric acid, hydroiodic acid, anything. To an unsymmetrical alkene, the hydrogen atom attaches itself to the carbon atom of the double bond with a larger number of hydrogen atoms. So that is how it is. So we'll see the example of it. There are basically two possible products when hydrogen halide reacts with an unsymmetrical alkene. So it is because the hydrogen halide molecule can add to the C double bond C bond in two different ways. That is, the unsymmetrical alkene can add HI, where HI can go to the carbon which has less number of hydrogen atoms, or I can go to that carbon which has more number of hydrogen atoms. So in the first case, what do you observe is iodine is going to the carbon atom which has more number of hydrogen atoms, and hydrogen is going to that carbon which has got less number of hydrogen atoms. So just in case if you're not able to identify, here this carbon is the carbon which has got less number of hydrogen atoms, and this one has got the more number of hydrogen atoms, and iodine is going to that carbon which has got more number of hydrogen atoms. In the second case, it's completely different. What do we observe is that in the second case, the hydrogen is going to that carbon which has more number of hydrogen atoms, and iodine is going to that carbon which has less number of hydrogen atoms. It is you are able to see in the example. Now the Markovnikov's rule says that the negative part will go to that carbon of the double bond which has got less number of hydrogen atoms. Okay, so that means this particular product what we have, okay, so the second product whatever we have, this one is according to the Markovnikov's rule, which is 2-idopropane. That is the major product. Why it is termed as major product? Because it is governed by the Markovnikov's rule. Okay, so that is how you have to make the products according to the Markovnikov's rule. Next is Saytzeff rule. Now Saytzeff rule is particularly for elimination reactions. Now what does Saytzeff rule say? Saytzeff rule say that a reaction that produces an alkene would favor the formation of an alkene that has the greater number of substituents attached to C double bond C group. Now there are two different ways, two different options where the dehydration of alcohols can occur. First one is 2-butanol. Okay, so here we have got 2-butanol, and that is hydrogen ion heat. Now in the presence of acidic medium, what do we observe? Now 2-butanol can undergo elimination reaction via two ways. Either it can form 1-butane or it can form 2-butane. Okay, so what it has been observed is कि जो 2-butene है, that is the major product. Okay, now why it is the major product? Because it is governed by Seitzef rule. And what does Seitzef rule say? Seitzef rules say that the elimination of hydrogen will be from that carbon which is more substituted. Okay, now what do you observe over here? We observe that here we have got two carbons. So OH obviously will be removed, that's for sure. And we have got this carbon and we have got this carbon, yeah, from where the hydrogen can be removed, because this is dehydration of alcohols. That means it has to be minus H2O. Okay, so माइनस H2O मतलब OH है और एक H और चाहिए. सो या तो इस कार्बन से H जा सकता है या इस कार्बन से H जा सकता है. Now what will happen? You will observe that the hydrogen will be removed from this carbon. The reason being, this carbon is more substituted. What do you mean by more substituted? More substituted means that this particular carbon is attached to two other carbons. Whereas if you observe, this carbon is attached to only one carbon. Okay, so that means the hydrogen will be removed from carbon number 2. Okay, this carbon. I count it from this side. Okay, so this one will be the carbon from where the hydrogen will be removed, and of course OH will be removed, so there will be removal of H, which is water. And what will be the product? Ultimately the product will be 2-butene, and that's what Seitzef rule says. We can understand Seitzef rule in the light of hydrohalogenation of haloalkanes as well. So here we have got 2-bromobutane, एंड 2-ब्रोमोब्यूटेन में अगर डिहाइड्रोहैलोजनेशन करेंगे तो एक हैलोजन तो ये ब्रोमीन जाएगा, और दूसरा ये है कि ये वाला हाइड्रोजन जाएगा कि ये वाला हाइड्रोजन जाएगा. Okay, so what do we observe is that this hydrogen, this particular one, okay, this one, yeah, so this one is it will be removed in the dehydrohalogenation, and therefore the product would be 2-butane. Major product would be 2-butane. Of course there would be a byproduct which is 1-butane, which will be formed as the side product. Okay, so next we move ahead with nomenclature and isomerism of aromatic compounds. And here we have got the definition of aromatic compounds. And what are aromatic compounds? Basically the replacement of one or more hydrogen atoms of the benzene ring or by alkyl, alkenyl, alkynyl or aryl group to form an aromatic hydrocarbon are called arenes or aromatic compounds. That means these aromatic compounds are basically they are known for their special aroma, and they are also called as arenes. So in most of the books you'll also find aromatic compounds as arenes. Okay, so the examples of aromatic compounds, very well known examples, are benzene, naphthalene, and two of the examples of aromatic compounds are also given as toluene and ethyl benzene, as you can see on your screen. Now, there are different types of aromatic compounds, but the point of interest, we have got the point of interest in the particular type of aromatic compounds, that is the benzene containing compounds. And mono-substituted benzenes or derivatives are where we have to go in this particular chapter. So, बेंजीन किसी भी एक हाइड्रोजन को रिप्लेस करके कोई नया सब्स्टिट्यूएंट लगा देते हैं तो वो हो जाता है हमारा मोनो सब्स्टिट्यूटेड बेंजीन और उसका डेरिवेटिव, ठीक है। जस्ट इन केस अगर एक हाइड्रोजन को रिमूव करके कोई सब्स्टिट्यूएंट लगाएंगे सो दैट वुड बी मोनो सब्स्टिट्यूटेड बेंजीन। अगर दो हाइड्रोजन्स को रिमूव करके सब्स्टिट्यूएंट लगाएंगे तो दैट वुड बी डाई सब्स्टिट्यूटेड, तीन हाइड्रोजन ट्राई सब्स्टिट्यूटेड. So that's how it goes. Okay, so first we will have a look as how does this mono-substituted benzenes look like. So mono-substituted benzenes are named by prefixing the name of the substituent group to the word benzene. Certain mono-substituted benzenes derivative are given with special names as well. सो यूजुअली क्या होता है, हम बेंजीन के आगे सब्स्टिट्यूएंट का नाम लगा देते हैं एंड यूजुअली द मोनो सब्स्टिट्यूटेड बेंजीन नॉमेनक्लेचर इज डन. सो यू कैन सी द फर्स्ट एग्जांपल इज chlorine in the benzene, so that is why it is chlorobenzene. Nitrobenzene, that's hydroxybenzene, and the common name is called as phenol. Okay, so yeah, that's phenol. Okay, that is amine. So because it's amine, its common name is aniline. This is benzene sulfonic acid, that is methyl benzene, also common name is toluene. This is acetophenone, benzoic acid, benzaldehyde, benzyl chloride, benzyl alcohol, and all of these are these derivatives of mono-substituted benzene derivatives. Now, there can be other forms of substituted benzenes, and there are di-substituted benzenes also. Now, when there are di-substituted benzenes, you have to see that it can be of two types. Whether the substituents attached can be of similar type or it can be of different type. So when it is of similar type, they are present on the benzene ring. Their positions are indicated by using the symbols ortho, meta or para before the prefixes. Okay, and these isomeric dimethyl benzenes are also called as xylene. So we see the example over here. What do we observe is we have got two similar substituent groups attached, CH3, CH3, like that. Okay, and we have got 1,2-dimethyl benzene, 1,3-dimethyl benzene, and this is 1,4-dimethyl benzene. Now 1,2-dimethyl benzene, if we consider this position as 1, this position as 2, the position 2 is called as ortho position, so that is why you got the name orthoxylene. Okay, the position 3 is called as meta position, and that is why you see the name metaxylene, and the position 4 is called as para position, and that is why you see this name as paraxylene. Okay, now these all forms are isomeric forms, because if you see the molecular formula would be same, but only they differ in the arrangement of the substituents in different positions, like ortho, para and meta. And usually the ortho, para and meta derivatives are not usually, always they are isomeric forms. Okay, so next we have got di-substituted benzenes or derivatives, and here again the di-substituted benzene where the two substituents are different. Okay, so the two substituents are different. The examples are here we have got ortho-nitrophenol, ortho-nitrotoluene, para-nitrotoluene, para-hydroxybenzoic acid, and we have got the examples of crisols also, which is orthomethylphenol, metamethylphenol and paramethylphenol. Okay, orthocrisol, metacrisol and paracrisol, all three are isomeric forms. So these are di-substituted benzenes with different substituents attached. Okay, So this is basically you have must have got an idea of isomeric forms of aromatic compounds. Basically तीन isomeric forms होते हैं जिसमें ortho, meta, para होता है. So these are all examples. One question was also given to you in the previous discussions where in the previous PDF were given. So there was one question explain the position isomerism in xylene. So this is the answer, that position isomers of xylene are orthoxylene, metaxylene, and paraxylene. Okay. Next, we have to see the directive influence of a functional group in a monosubstituted benzene. That is why I told that the point of interest in all the aromatic compounds are the monosubstituted benzenes. That's where we have to put our focus on. Okay, so when monosubstituted benzene is subjected to further substitution, three possible disubstituted products are not formed in equal amounts. In fact, two types of behaviors are observed. Either ortho and para products are formed or meta product is formed predominantly. This behavior depends on the nature of the substituents already present in the benzene ring and not on the nature of the entering group. This is known as directive influence of the substituents. Basically, आप इसको ऐसे समझिए कि जब हम कोई भी रिएक्शन करते हैं तो ऑर्थो, पैरा, मेटा तीन प्रोडक्ट्स मिलने के बजाय दो प्रीडोमिनेंस प्रोडक्ट फॉर्म होते हैं, या तो ऑर्थोपैरा या मेटा. एंड विच वन विल बी फॉर्म्ड, आइदर ऑर्थोपैरा और मेटा में से कौन सा वाला प्रोडक्ट फॉर्म होगा, ये डिपेंड करता है इस चीज़ पे कि जो ग्रुप अटैच्ड है, जैसे कि सपोज अगर मोनो सब्सटीट्यूटेड बेंजीन है तो एक हाइड्रोजन को हटा के कोई सब्सटीट्यूएंट लगाया होगा, एच को हटा के ओ एच लगाया तो बन गया फिनॉल. या तो वो फिनॉल का जो ओ एच ग्रुप है वो डिसाइड करेगा कि प्रोडक्ट ऑर्थो पैरा डेरिवेटिव होगा या मेटा डेरिवेटिव होगा. ठीक है, दो ऑप्शंस हैं, या तो ऑर्थो पैरा बनेगा या मेटा बनेगा. नाउ डिपेंडिंग ऑन इसके अकॉर्डिंग ही हम डिसाइड करते हैं कि कौन सा ग्रुप किस तरीके का है. मतलब ये जो डायरेक्टिव इन्फ्लुएंस है, इट हैज़ गॉट टू टाइप्स ऑफ ग्रुप्स. वन इज कॉल्ड एज ऑर्थो पैरा डायरेक्टिंग, मतलब सब्सटीट्यूएंट जो डायरेक्ट करे इनकमिंग सब्सटीट्यूएंट को कि वो ऑर्थो पैरा पोजिशन लेगा, और अगर जो ऑलरेडी सब्सटीट्यूएंट अटैच्ड है वो इनकमिंग सब्सटीट्यूएंट को मेटा पोजिशन डायरेक्ट करेगा तो वो मेटा डायरेक्टिंग ग्रुप है. ओके, सो देर आर बेसिकली टू टाइप्स ऑफ ग्रुप्स as far as the directive influence is concerned: ortho para directing group and meta directing group. We'll try to see it with an example. So ortho and para directing groups, the groups which direct the incoming group to ortho and para positions are called ortho and para directing group. As an example, let us discuss the directive influence of the phenolic OH group. The resonance structures of the phenol show that the overall density on the benzene ring increases in comparison to benzene. Therefore, it is an activating group. Now, please try to understand what is happening over here. OH group is is increasing the electron density in the benzene ring, and that is why अगर कोई substituent यहाँ पे आ रहा होगा तो ये ऑर्थो और पैरा पोजिशन, अगर आप देखें तो नेगेटिव जो चार्ज है वो ऑर्थो और पैरा पोजिशन पे ही रेजोनेट कर रहा है. या यू कैन सी ओवर हियर ऑर्थो पैरा ऑर्थो अगेन. ओके, सो नेगेटिव चार्जेस ओवर ऑर्थो. एंड OH ग्रुप क्या कर रहा है? OH ग्रुप इज एक्चुअली इंक्रीजिंग द इलेक्ट्रॉन डेंसिटी इन द बेंजीन रिंग. या So that is why we will call this as activating group. और एक्टिवेटिंग ग्रुप के साथ ये ऑर्थो पैरा डायरेक्टिंग ग्रुप भी है. मतलब ऑर्थो पैरा पोजिशन पे जो इनकमिंग सब्सटीट्यूएंट है वो ऑर्थो और पैरा पोजिशन पे आके अटैच होगा. ओके, मेटा डायरेक्टिंग ग्रुप. मेटा डायरेक्टिंग ग्रुप, the group which directs the incoming group to the meta position are called as meta-directing groups. Some examples of meta-directing groups are NO2, CN, CHO, COR, COOH, COOR, SO3H, etc. Now let us take an example of nitro group. You can see the resonating structures of the nitro group. And what do you observe over here is कि आप नाइट्रो ग्रुप में देख रहे हैं कि instead of the negative charge, the positive charge is over the ortho para positions. Okay. Now that means अगर कोई substituent को आना होगा तो वो ortho para position पे तो नहीं आएगा, और अगर जो substituent आएगा वो इलेक्ट्रोफाइल होगा. ठीक है, तो वो इलेक्ट्रोफाइल का मतलब है कि वो पॉजिटिवली चार्ज होगा. तो पॉजिटिव चार्ज पॉजिटिव वाले केस में नहीं आएगा, ऑर्थो ये वाले पैरा पोजिशन पे भी नहीं आएगा, इस वाले ऑर्थो पोजिशन पे भी नहीं आएगा. तो यहाँ पे बचा जो क्या, कौन सी प्लेस बची एक मेटा पोजिशन, ये या सो इस वजह से जो नाइट्रो ग्रुप है वो इनकमिंग इलेक्ट्रोफाइल को डायरेक्ट करेगा कि आप मेटा पोजिशन लीजिए, नॉट ऑर्थो एंड para positions. Okay, so that is why nitro group reduces the electron density in the benzene ring due to its strong minus I effect, and that is why nitrobenzene is the resonance hybrid of the following structures, and that is why nitrobenzene will be the deactivating group. Okay, so that is how it works. An electron donating group, you can see over here. So electron donating groups would be the activating groups like this, all these, and electron withdrawing groups like in nitro and all, so all would be deactivating groups because they would be taking away the electron density. Okay, so here are the list of the activating and the deactivating groups. On the left hand side you see the activating groups, and on the right hand side you see the deactivating groups. That is a different thing, strongly deactivating or strongly activating, but basically the baseline differs you from the activating groups and the deactivating groups. Okay, now benzene and monosubstituted benzenes preferably undergoes electrophilic substitution reaction. Means one hydrogen is removed, and instead of that hydrogen, a positively charged species, that is an electrophile, comes into and takes the position, whether ortho, para, meta, depends. Okay, depends on the directive influence. Okay, so what is basically the electrophilic substitution reactions? This is the most important part of the chapter. Most important part of the segment of aromatic compounds, that is electrophilic substitution reaction. Electrophilic substitution reaction in benzene occurs when an electrophile substitutes an hydrogen atom in benzene. That's what I told you. Electrophilic substitution in benzene takes place in two steps generally. The first step of the electrophilic substitution in benzene synthesis is the formation of a benzyl conium intermediate, also called as sigma complex. This intermediate is resonance stabilized and has 4 p electrons, making it more reactive than the original aromatic ring. However, this reaction does not proceed as quickly as an electrophilic addition to an alkene. Okay, so basically the point is that there would be an electrophile and that would be attacking on ortho, para or meta position, because benzene overall is negatively charged. This is how the process goes. Here we have got an electrophile, and this electrophile attacks on the benzene, and benzene has to remove one hydrogen, and over here there is one carbocation which is being formed, and this hydrogen gets shifted to the Lewis base. We'll introduce a Lewis base, and Lewis base takes up that hydrogen, and ultimately it forms an HB, and that electrophile goes and attaches itself from where the hydrogen got replaced. Okay, so this is basically the electrophilic substitution reaction. Now, there are different types of electrophilic substitution reaction, but just for the case of understanding what is basically it is, we'll have an example. So the next reaction that we have to see in the example of electrophilic substitution reaction is Friedel-Crafts reaction. Okay, we'll see that again, but just in order to understand, let's have a view. Okay, so the Friedel-Crafts acylation in benzene is a chemical reaction that attaches a substitute to an aromatic ring. The process involves adding a methyl or an ethyl group to a benzene ring, which is an electrophilic aromatic substitution reaction. Benzene is an example of a chemical that can undergo this reaction. So here we have got an aromatic compound, which is benzene, and the other one, which is the reagent, is this is benzene. This is the reagent, which is acetyl chloride. Okay, so acetyl chloride in the presence of AlCl3. Please remember, this is a very important reagent. AlCl3 acts as a Lewis acid. Lewis acid takes the electron pair. Remember that. Okay, so what happens that when this AlCl3 abstracts this chlorine and becomes AlCl4, yeah, and over here this particular carbon gets a positive charge. So this CH3CO becomes an electrophile and goes and attaches over here. So hydrogen gets replaced and this electrophile attaches over here. So in return we get a acetophenone over here, yeah, and we've got one HCl, so Cl plus H. So that is what we have got. Next is the nitration of benzene. So nitration of benzene में भी similar case होता है. Nitration HNO3 में से NO2 produce होता है. Okay, so here we have got NO2 plus produced, and this NO2 plus attacks on the benzene. Here we've got hydrogen and NO2 attacked, so that is what it is. So there's one water molecule. This water molecule abstracts the hydrogen and becomes H3O plus, and this we have got a nitrobenzene. Now there are different types of electrophilic aromatic substitution reactions going on. The point where we like the important ones are halogenation, where replacing with chlorine or bromine takes place. Nitration, replacing with a nitrate NO2 group takes place. Sulfonation, replacing with bisulfide SO3H group takes place. And Friedel-Crafts alkylation, replacing with alkyl group R, and Friedel-Crafts acylation, replacing with acyl group RCO. That's what we have seen in the first example. This is what the list of the electrophilic substitution. This is what the list of electrophilic aromatic substitution of benzene looks like. So here we have got benzene, which reacts with chlorine and gives FeCl3, chlorobenzene, and HCl is formed. Then benzene reacts with, if benzene will react with nitric acid in the presence of H2SO4, it will give nitrobenzene. If benzene will react with sulfur trioxide in the presence of H2SO4, it will result into benzene sulfonic acid. And benzene, if reacts with methyl chloride or acetyl chloride, gives toluene and acetophenone respectively. So these are the electrophilic aromatic substitution reactions given by benzene majorly, and these are very important reactions. So basically from this chapter hydrocarbon, this aromatic compounds reactions are very, very important. Alkenes, and alkynes reactions you have already studied before, but the important ones in this is the Markovnikov's rule and the Saidzev rule. This is what the most important part of the hydrocarbons are, and this would be very important as far as class 12 is also concerned. So I think that's all for today's discussion of the class. Thank you.